Okay guys, so in section P.3, we're going to be talking about writing polynomials in standard form, adding, subtracting, and multiplying polynomials, and using our special products. And then we're also going to do a real life problem. So this is, again, another section of review. You guys should know a lot about polynomials still from Algebra 2. Some examples of polynomials are anything really with terms separated by addition and subtraction. So we could have something like 2x plus 5, 3x to the fourth minus 7x squared plus 2x plus 4. Then we could also have something like 5x squared y squared minus xy plus 3. Now the two polynomials in blue are called polynomials in x, and the one in red is called a polynomial in x and y, since there are x and y's. Some vocab that goes along with this section that you should be familiar with. First of all, we have monomials, binomials, and trinomials. A monomial is a polynomial with one term, a binomial is a polynomial with two terms, and a trinomial is a polynomial with three terms. Some others, remember we have our degree, which is the largest exponent. So our degree in this example up here would have been 4. We have coefficient. So a coefficient, remember, is anything being multiplied by a variable. And then we have our leading coefficient. So our leading coefficient is always on the term with the degree. So in this example up here, it would have been 3. In this example up here, it would have been 2. With degree, remember they all have specific names. So something with a degree of 0 would be constant. Something with a degree of 1 would be linear. Something with a degree of 2 would be quadratic. Something with a degree of 3 would be cubic. Those are the ones we work with most. 4 would be quartic. I'm going to just put it up here. I did make you memorize that in Algebra 2. And 5 would be quintic. Okay. When we get above that, we usually just say degree 6, degree 7, degree 8, and then so on and so forth. Those are the ones I did make you memorize last year. Writing polynomials in standard form. Remember, standard form is decreasing order of exponents. So we want the biggest exponent to come first. And then we want to list the degree and leading coefficient. So I think it's easiest to first put the polynomial in standard form. So I look and I see that this has the biggest exponent. So I'm going to say negative 5x to the 7th. Then 4x squared, because the x squared is my next biggest exponent. Then 3x, then minus 2. So that would mean my degree is 7, and my leading coefficient is negative 5. So pause the video and you guys try B. It would be negative 9x squared plus 4 My degree would be 2, and my leading coefficient would be -9. So this is a quadratic, and the graph would be a parabola, which you learned last year. Part C, this is a constant because there's no x. This would be like 8x to the 0 power. But remember, anything to the 0 power is 1. So it's just 8. So it is in standard form already. That means the degree is 0. And the leading coefficient is 8. You can pause me and try D on your own, but it would be -7x cubed plus 2x plus 6. 3 would be your degree, so it is a cubic, and your leading coefficient would be -7. A polynomial that has all 0 coefficients is called the zero polynomial, and it's denoted by 0. So it would just be like C, except it would be the number 0. Okay, operations with polynomials. We can add and subtract polynomials in the same way we add and subtract real numbers, by combining like terms. So in this example, we're going to write the sum or differences of polynomials. In part A, it's going to be pretty easy. All we need to do is match up our like terms. So 5x cubed and x cubed, 7x squared and 2x squared, -3 goes with the 8, since neither of them have a variable. And then this -x is just all on its own. So since we have addition in the middle, we're just going to add, not worry about the signs. So 5x cubed and x cubed is 6x cubed. -7x squared and 2x squared is -5x squared. Then we have minus x, and then we have plus 5. Now with B and C, you should notice that this is a negative sign. That's like we have a -1 and we need to distribute it to the second set of parentheses. So you need to be really careful. Some of you might be able to do this in your head, but I would recommend still running the negative through just to be safe. I sometimes even do it. So if we would have 7x to the 4th minus x squared minus 4x plus 2 minus 3x to the 4th minus a minus 4x squared is plus 4x squared minus 3x. Now I can combine like terms. So I have 7x to the 4th minus 3x to the 4th, which is 4x to the 4th. I have -x squared plus 4x squared, which is plus 3x squared. I have -4x and -3x, which is minus 7x. Then I have plus 2, and then nothing on the back, so that's just plus 2. So go ahead and pause me and try C. It would be 2x cubed minus x plus 3. When I run the negative through, I would get -x squared minus a -2x is plus 2x minus a -3 is plus 3. When I combine like terms, I don't have anything like with 2x cubed, so that's just 2x cubed. -x squared would come next in standard form, so I'm going to write that next. There's nothing like to combine it with, so I'm going to write -x squared. Then -x and positive 2x, so that's positive x, and then positive 3 and positive 3 would be positive 6. So there's your final answer. All right, on the next page, moving to multiplying polynomials. We can multiply polynomials using the distributive property. We used to call this FOIL. Last year in Algebra 2, we used the box method for the more complicated ones. And then I am going to show you a brand new method here that this book uses. So we're going to use a few different methods, and you can use your choice of whatever you want whenever the time comes. So your pick. But when we have a binomial times a binomial like this, I just double distribute. So I take the first times the first, which is 2x squared. Then I take the first times the last, which is plus 10x. Then I do the same thing with the last term. So I take these two, so minus 4x, and then the last two, so minus 20. You can probably do that in your head and not have to show this step, but I'm just showing it for the notes. So 2x squared plus 6x minus 20. And there's your answer. So pause me and try this one. I'm just going to write the answer so you can check your work. So, in the next example, we have a trinomial times a trinomial. Okay? Now, your book does a vertical multiplication arrangement that I do want to show you. And then on part B, I'm going to reintroduce box method to you guys. So I did want to show you that as well. So your book does this vertical multiplication method. So I'm going to line them up vertically. So I have x squared minus 2x plus 2. Then I have x squared plus 2x plus 2. So we take the first term in the bottom one and distribute it through all three. Then we take the second term in the bottom, distribute it through all three. Then the third term, distribute it through all three. Then we're going to put each answer vertically and then add them vertically. So it's just another way basically of organizing our work. So I'm going to take x squared and distribute it through x squared minus 2x plus 2. And I'm going to get x to the fourth minus 2x cubed plus 2x squared. So that was my first step. I took this term. Now I'm going to take 2x and distribute it through x squared minus 2x plus 2. And I get 2x cubed minus 4x squared plus 4x. So that step's in green. Now I'm going to take 2 and multiply it through my top one. So x squared minus 2x plus 2 and multiply it through. So I get 2x squared minus 4x plus 4. And I arranged it like this, staggered like this, so that like terms would be one on top of each other. So I have x to the fourth and nothing below it. So that means that I have no like terms to add to x to the fourth. So x to the fourth is in my final answer. Now, whatever's below it is a like term. So I have negative 2x cubed plus 2x cubed, which cancels each other out. I have 2x squared minus 4x squared plus 2x squared. That cancels each other out. Then I have 4x minus 4x, which cancels each other out. Then I have 4. So when I look at what I have left, it's x to the 4th plus 4. And that would be my final answer. So you do not have to do that. It's exactly like distributing 3 times and combining like terms. It's just another way I wanted to show you how to organize your work. On B, you can try it yourself if you want to pause me, but I do want to run through box method one more time. So I put x squared, 2x, and 3 on my top row. And then I put x squared, negative 2x, and 3 on my bottom row. And I draw my little box. So I multiply x to the 4th. X squared times negative 2x is negative 2x cubed. X squared times 3 is 3x squared. 2x times x squared is 2x cubed. This is negative 4x squared. This would be 6x, 3x squared, negative 6x, and then 9. And then remember, in between, within the boxes, you add. So 2x cubed plus negative 2x cubed is 0. 6x plus negative 6x is 0. 3x squared plus negative 4x squared plus 3x squared is 2x squared. So I have x to the 4th plus 2x squared plus 9 as my final answer for this multiplication problem. All right, now we're getting to special products. So these were the things I beat into your head in Algebra 2 and that some of you still didn't like to remember. So sum and difference of same terms. When we factored this was a difference of 2 perfect squares. So when we have something plus something and then that same something minus that other same something, we can just square them and stick a subtraction sign in the middle. So an example would be that if I have x plus 4 and x minus 4, I can do x squared minus 4 squared, which is just x squared minus 16, and be done with it. Square of a binomial. This is the whole double the squash thing that you guys hated. So I'll do one with an addition. So if I have x plus 3 squared, you square the first, you square the last, and that one's always positive, and then you double the squash. So the squash is you multiplying these two together. So 3 times x would be 3x, doubled would be 6x. And since this is an addition, this is going to be addition. Now, an example of the subtraction would be if we had 3x minus 2 squared. So if we square the first term, 3x quantity squared would be 9x squared. Square the last term would be 4. We're doubling the squash, and since it's subtraction, this term has to also be subtraction. So the squash is 3x times 2, which is 6x. Doubling that, we would get 12x. So I would always figure out the squash first and then figure out what it would be doubled. And then finally, the cube of a binomial. This pattern is pretty helpful because it keeps you from having to sit there and double distribute and then double distribute again. So you can just flip back to this pattern and figure it out from there. So if I give you x plus 2 cubed, you know that your x is like your u and your 2 is like your v. So I have, following this pattern, I have x cubed plus 3x squared times 2 plus 3x times 2 squared plus 2 cubed. So all I did was plug my x and my 2 into this pattern right here, squaring and cubing as needed. So now I'm just going to multiply through. So I get x cubed plus 6x squared plus 12x plus 8. The cube of the binomial that is subtraction is really similar, except we just changed 2 of the signs. So if I gave you x minus 1 cubed, x would be your u again, and 1 would be your v. So I would get x cubed minus 3x squared times 1 plus 3x times 1 squared minus 1 cubed. So notice the 2 signs that were negative, that were subtraction instead. So since this is 1, it's really easy to do. So x cubed minus 3x squared plus 3x minus 1. Okay, trying to go to the next page. So here's all these examples to multiply. So I want you to try all these examples. I'm going to put the answers. So pause me, try them. I'm going to fill in the answers. So 25x squared minus 81. 9x squared minus 4. Square the first. Square the last. Double the squash. It's negative, so it's the 60x is negative. Square the first. Square the last. Double the squash. These two are a tad bit harder. So I'm going to show you my steps. Okay. There's that one. Here's the difference. Just on these cubed ones, just look back at those patterns. Remember, you don't have to use those patterns on these. You can always just multiply it out if you want to, I guess. Uh-oh, I'm running out of room. I'm just going to write my answer for B. My answer was 64x cubed minus 48x squared plus 12x minus 1. Okay, in example 8, find the product of two trinomials. Sometimes instead of using box method that could take a minute, if we're able to break this down and make it look like one of our special products, then we could maybe make it go a bit faster. So I noticed that there's a +2 and a -2. And then there's an x plus y in both. So I'm like, okay, what if I group that x plus y minus 2 times the x plus y plus 2. Now, it's a sum and difference of same terms. It's one of our special products. So I just have to square the first, subtract, and square the last. So I have x plus y squared, subtract, and square the last. Now this is a square of a binomial, which is one of our double the squash. So I square the first, square the last, and I still have my -4. That's from here. And then I double the squash. So since it's plus, double in the squash is xy. So you pause me and try B. It's very similar. You just group it like x minus 2 plus 3y, x minus 2 minus 3y. So it's a sum and difference of same terms. So I'd have x minus 2 squared minus 9y squared. Don't forget to square the 3 and square the y. So when I double the squash here, I get x squared plus 4 minus 4x. And don't forget that minus 9y squared. Finally, we have our word problem. An open box is made by cutting squares from the corners of a piece of metal that is 16 inches by 20 inches. Okay, so part of the assignment I gave you was to actually draw a picture. So I have a 16-inch by 20-inch piece of metal. So they cut out squares from the corners. Hopefully your squares look a little bit better than mine. Oh my goodness, my squares are terrible. That's okay. Find the volume. The edge of each cutout square is x inches. So each of these is x inches long. Find the volume of the box in terms of x. Draw the diagram and then solve the problem. So then we're also trying to find the volume when x equals these three values. Okay, so when they cut, and they're going to cut these squares out. When they cut that out, they're going to have a folded box. And you guys know what a folded box looks like. Mine's probably going to be pretty hideous. I promise it looks better on my paper. We know that our height is x because they give us that that is x inches tall because they just told us that that's what it's cut out. Now, our length used to be 20. We got to figure out what our new length is, which is this. Let me do a different color. We got to figure out what our new length is, which would be this, and what our new width is, which would be that. Because remember, volume is length times width times height. So, our new length would be that, and our new width would be that. So our length used to be 20, but then they cut off a length of x on this side, and they cut off a length of x on this side. So our new length is 20 minus x, which is 20 minus 2x. So 20 minus 2x is our new length. Similarly, our new width is 16 minus 2x. So 16 minus 2x. So our volume is length 20 minus 2x times width 16 minus 2x times height, which is x. When we multiply that out, you should get 320 minus 72x plus 4x squared times x. So then when you distribute the x, we get 320x minus 72x squared plus 4x cubed. So now all you have to do, we have to figure out when x equals 1, when x equals 2, and when x equals 3. So we got to plug in 1, we have to plug in 2, and we have to plug in 3, which you can probably do in your calculators. So when you plug in 1, you get 252 cubic inches. Since it's volume, it's cubic inches because we have 3. 1, 2, 3. When we plug in 2, we get 384 cubic inches. And then when we plug in 3, we get 420 cubic inches. So there we go. There is our application problem. So here's your homework for this section. This is what is due to me for everyone. Now I also included this practice. Please do not do all these problems. This is just if you want some practice. I don't think any of you will need it, but just in case, there's plenty of it in the book. Your homework for tonight isn't a bunch of busy work, so I just included some practice in case if some of you wanted some of it. So I'll see you in the next video. So great job today. See ya.